Hello, Yawning Angel, back again, another AMOS video where we're going to be talking about bobs, Blitter Objects. So in my last video, I looked at how to control a bob on the screen by using a joystick. There's a link up here somewhere to that video. That went really well, but now let's up the ante and let's look at how to detect a collision between two bobs. You know no one's going to get that joke unless they know what Blackadder is. So in this video, we're going to have two Blitter objects, bobs, on the screen. We're going to have one moving up the screen and another one which is static. And we're going to write some code to detect when they collide. Dead straightforward. So without further ado, let's get into it. So let me just show you what I've got in my bob bank. So I've got 1, 2, 3, 4 images in here. That's the first one of my spaceship. Look at that little ship there. And then the second version of that. I've changed some of the colouring around here. So when these images are alternated between quite quickly, it gives it that sense of animation on the object. I've got a little grey asteroid here. And I've got a little blue asteroid. So those are the 4 images which are in that bob image bank file. Nice. Okay, so here we are in the code. So I've already put this together. So I've got my comments and all the steps which we're going to undertake to get this program working. So let me just quickly take you through it. First thing, we're going to, step 1, we're going to set our screen up. Step 2, we're going to load our bob bank and set that up. Then we're going to mask the bobs. Very interesting, that's new. We're going to define some variables and initialize them. We're then going to place our static bob or bobs on the screen. Then we've got our main control loop in the program. And then outside of that, we've got a procedure for displaying the static bob. That's the thing that the moving bob is going to crash into, sorry. Then we've got a procedure for handling our joystick input, and then we've got a procedure for detecting any collisions, which is the whole purpose of this video and this program. So that's very important. Right, so what I will say is this source code and the bob bank I'm going to upload to my website so you can download it once you've seen this video. Because last time I didn't include the bob bank, but this time I will. Right, well, let's get on with it then. So we're going to define our screen first of all. So it's going to be screen open 1, and that will be 320 by 200 by 16. It's going to be low res. Okay, and then we're going to clear the screen to color 0. We're going to turn our cursor off. We're going to turn any flashing off. And we're going to hide the mouse. I always put this comment in because hide on its own confuses me. Rem hide the mouse, mouse cursor. Okay, step 2, load the bob bank. So your mileage will vary on this, but I'm defining a directory where my bob bank is. So let me do this properly. So concentrate, Yawning Angel. DH1, and it's in programming, and it's in AMOS Pro source, and it's in my vlogs directory. Okay, and then we're going to load the bob bank file in, and we're going to load test underscore ship underscore 2. And 2.abk is the suffix on that. Okay, I'm not very good at naming files, and when I'm testing stuff I start by calling them test, and then they come to completion and they're still called test, so I haven't changed the name on that. Right, so then we're going to get the bob palette. So this gets the color profile of that bob bank and loads that in. Then we need to double buffer. So that was mentioned 2 videos ago now. We looked at that. If you don't know what that is, take a look in the AMOS Pro manual. Right, then we're going to mask our bobs. Now, masking bobs, very important for detecting collision. So what AMOS will do is put a mask around each bob that it loads in, and this aids with the collision detection. You might think this is a little bit complex, but this is AMOS Pro, it's easy. All you have to do is type in make mask, and that's it. That will assign a mask around each bob object which is loaded in from the image bank. How good is that? Right, so step 4 then, what we're looking at here is creating some global variables. So we're going to have x_pos. I'll explain these later. Global y_pos. So that's my x and y position of the bob I have on the screen. Global bb number. That will be a bob number. Global ship_speed. Guess what that is? Global, we're going to have h hash. Global, and we're going to have hit_counter. You probably noticed I'm using a mixture of uppercase and lowercase here when I'm typing this in. It doesn't matter because AMOS makes it all uppercase as soon as I hit return, so that's not a problem. Global b hits. There we go. Right. Now we're going to initialize those variables. So the next thing we're going to do is we're going to start off with x_pos equal, what's that going to be? 120. Y_pos is going to be 160. So that's my x and y coordinates for my moving bob. That's where that's going to start off on the screen. Ship speed will set to 2, and bb number will set to 1. Okay, so that's that. So place static bobs. So all we're going to do here is call a procedure called static bobs. Okay, and what I'm going to do is dive down to the bottom and quickly just put some code in to define that procedure. Procedure static bobs and proc. If we do that now, it means we can actually run the program, and of course the procedures there will allow it to run, even though it's not actually doing anything. So main loop. So our main loop, we've got a do loop, and outside of that we've got an end. So that is that. Right, so the first thing to do then is get a mouthful of tea, because that's quite important. Tea helps me think. So first off, we're going to set the movement speed of the ship. So set movement speed of ship. Or really this should say set the ship moving, because what I'm going to have here is a graphic of a little spaceship moving up the screen automatically. So what we're going to say is y_pos will equal y_pos minus ship speed. So what we're saying here is the y position, so that's the vertical axis, is going to subtract the ship speed from it each time. So that will move it up the screen. So because if you want to move it down the screen, you'd add the ship speed, because remember you take numbers off to go up and add numbers on to go down. Now here's something a little bit trick. I've got 2 bobs for my spaceship, and they're slightly different, and it gives a sense of animation. So what we're going to do here is set the bobs to show for ship, and we're going to alternate them. Okay, alternate them between 2, because we've got 2 bobs. This will make sense in a moment. So what we're going to say here is bb number equals a random number between 0 and 2. Okay, 0 and 2, even though we've only got 2 bobs. So I mean, there's a number of ways you can cut this and do it your own way. This is the way I'm doing it. And what we're going to say here quickly, because we don't have a bb0, we've only got 1 and 2, we're going to say if bb number equals 0, then bb number equals 1. So if a random number is returned and it's 0, we're just going to set it to 1. If it's 1, it's 1, and if it's 2, it's 2. Dead easy. Okay. Then what we're going to do, so we're going to say if at the top of the screen, reset to start. Because our ship's moving up the screen, you'll see that in a minute, and if we get to the top, we just want to set it back down to the bottom. So remember, this is quick and dirty code, so don't worry too much about the finesse. So if ypos equals 0, so if we've got to the top, we're going to say ypos equal 160, so reset that, and we'll end if on that. Okay, so now what we're going to do is actually place our bob on the screen. So rem position our spaceship bob. Right, so remember, so bob, our first bob, is going to be positioned at x coordinate, comma y coordinate, and it's going to be BB number. So remember, BB number's been set here, so that will just keep on alternating between image 1 and image 2 of the ship. So let's see, so I've got a syntax error there. Why have I got a syntax error? Bob1, comma, oh, that's why, because I've mistyped that. That should be a comma. There we go. F2 obviously checks your code for errors. So let's give that a quick run and see what happens. So we've got a rather messy animation going on there. So let's Control-C out of that. So what you'll probably notice is I've missed out something really important, and that is the wait VBL command. Wait for the next vertical blank line. So AMOS needs this. What it does, it waits for the next horizontal blank line when refreshing the screen, and then redraws the screen. So now if I run that, there we go, a little bit smoother. As you can see, spaceship moving up the screen, looking good. We've got no control on the joystick yet, but that doesn't matter. So Control-C out of that. Right, now we need to handle the control of the joystick, hit detection, and exiting the program and all that good stuff. So we'll do that next. Right, quick mouthful of tea. Need to readjust my chair, that's better. Right, let's get to the right bit of code. So we've done our wait vertical blank line. Next up, we're going to handle our joystick input. Handle joystick input. Just F3 to indent that. Oh, blimey. And all we're going to do is call a procedure called sticks for that. And what I'm going to quickly do is dive down here and just define that procedure. Procedure sticks and proc. Good. Next up is the exciting bit. We're now going to handle collision detection. Right, so what we're going to do here is call a procedure called hit detect, and we're going to pass in a value of h hash. So square brackets, h hash, close square brackets. And what I'm going to do is go down here quickly and start to define that in step 6.3, detect any collisions procedure. So this is procedure hit underscore detect, and we pass in h hash. Don't forget the square brackets. End proc. Right, okay. So this is where it gets interesting. So what we're going to say in here is h hash will equal bob col 1. What is this line doing, Yawning Angel? So bob col is detecting a bob collision. And what happens here is, what this will do, will return a -1 if a collision is detected. So if bob col 1, so 1 is the actual value of the bob which we're checking. So in this case, this will be our spaceship. And it's going to return a -1 if we detect a collision. Okay, have you got that? So bob col, and the number in brackets is the number of our bob, which we're checking to see if it's hit something. Now, I'm going to put an extra piece of code in here, which we're not really going to use in this program, but you can go forward and use this to your heart's content, really. We can detect which bob has been hit. The thing is, we know for this program we're only going to have two bobs on the screen, our moving ship and our little asteroidy thing. But if you wanted multiple asteroids, you could then check and see which one your spaceship has hit, and you'll do it this way. So find out which bob was hit. Okay, and what we're going to say is b underscore hit, that's where it's going to store the value, will equal col minus 1. That will actually return the numeric value of the bob which was hit. You will see it in action in this program. It's always going to return the same value because we're always going to hit the same object, but it's something to bear in mind. What we need to do at the end of the procedure, of course, is return the value of h hash. That's really important because that's telling the calling piece of code that a collision has or has not occurred. Right, still with me? Stick with it. We're doing well. So let's come back up here, and so we call our hit detect procedure, and then what we're going to say is, well, has a hit been detected? So if h hash equals -1, it returns a value of -1 if there's been a collision. We can make a sound effect called boom. That's built into AMOS. That does work. And then we're going to set our hit counter value. Hit counter equals hit counter +1. That's fine. Then we're just going to quickly dump this on the screen. This is very messy, this piece of code. You might want to tidy this up. But all I'm going to say is locate 0, 0 on the screen, print hits, colon, space, and then we'll have semicolon hit. So we'll actually print the hit counter on the screen, and then we're going to say locate 0, 1, and we're going to have print bob hit, and that will be b underscore hit. Glory of global variables here, I can use b hit without having to return it. I could have probably done the same with h hash as well. Don't lose any sleep over it. This all still works. Then what we're going to do in here is rem reset ship position, because as soon as we hit something, I want to move my ship back to the start point, just because I do. Xpos equal ypos equals 160. Ypos equals 160 and xpos equals 120. Okay, and then we're just going to end if there, and then we're going to put in how we exit this piece of code. So if the fire button has been pressed, we're just going to exit the program and end if there. Oh, I made a mistake there. Let's just quickly change that. No errors. Right, good. Now we need to put in some joystick control, so we will do that next, and we've actually got to then position our static bobs. We mustn't forget to do that. So let's do that next. Okay. Right, what I've done here, I've actually put the code in for the joystick control because you didn't need to see me type all this again. But we're doing something, excuse me, we're doing something a little bit different here. So if you press up on the joystick, bear in mind our spaceship's moving up the screen and it has a speed set already. So if you move the joystick up, the ship speed is set to 2. If you move the joystick down, the ship speed is set to 1. So you can only control the speed of the ship going up the screen. You can't move down. But you can move left and you can move right. So that's dead straightforward. So let's run this and see what happens. So I've got no errors. F1 to run, and there's my ship moving. So I can go left and right, like that. And it's moving at a bit of a lick. So now if I pull down on the joystick, you notice it slows down. And if I push up, the speed increases. And there's an error there, which means it falls off the screen. But you get the idea. That is a bug which I do not address in this code. I need to look at that further on. But you know, you get the idea of what's happening here. Right, so what we need to do finally is actually position our static bob. So we need our little asteroid to appear on the screen. So rem define one fixed static bob only, because this is just to show you how this works. So we're going to say bob, And in this case, it's going to be our third Bob, because don't forget, we've got Bob 1 and Bob 2 are our two different graphics for the ship. So Bob 3 is now our asteroid. And we're just going to dump this at a fixed position. And it is the third Bob in the image bank. So remember that with the numbers. The first number is which Bob this is in the program. And the final number is the Bob that you're taking from the image bank. Okay, so we've got no errors. So if I hit F1 now, move the ship out of the way, you can see I've now got a little asteroid on the screen and I'm flying, and if I hit it, you see what happens there? I've got a hit registered and it's telling me that I hit Bob number 3. It will say that because I've only got one Bob on the screen. So let me just close that off now. So what I've got here is telling me that I've hit that 4 times and the Bob number has been returned as that is Bob number 3, which is what we set that at anyway. So that code is working. So that really is all there is to this program. It's fairly straightforward. Bob collision detection is really simple. AMOS has got all this baked in. This command here, Bob col, check which Bob, our Bob number 1 has hit, and then tell me which static Bob that's actually hit on the screen. This is really simple and straightforward stuff. You kind of think this is going to be quite complex, but AMOS was geared around this type of stuff, so a lot of these commands are baked in to the code. And that really is all there is to it. Fairly straightforward. And whoops, let's run that. I'm quite happy with that. So, you can take this code and advance it. You can put more Bobs on the screen for it to hit. You can change the animation of your ship. You can increase the speed. You can do whatever you like. But this is just the bare bones code. And you can see this is fairly accurate. Look at that. As I detect, look at that, as it just nudges it, it registers that as a collision. Oh, just missed it that time. Collision detected. Really straightforward stuff. Love it. So one thing I thought was worth maybe doing here for our static Bob that we display on the screen, the asteroid, we're bringing in the third object, which was our grey asteroid, and we're assigning that to Bob value 3. So let me change this to the fourth one, which should be our blue asteroid. Okay, so no errors on that. So our fourth Bob object is assigned to our third Bob in the program. Does that make sense? So Bob 3 in this code is actually taking the fourth image from our bank. So if I run that, we should see a blue asteroid. So that's appeared on the screen nicely. But if I hit that now, as you'll see, I'll stop the code there. So we've hit it once, but the Bob number that it's hit is number 3, because that's what we've assigned it to in the program, even though it's the fourth Bob in the image bank. Okay, just wanted to be clear on that. So you can chuck in whatever you like there, but whatever number you assign it to in your code, that's the Bob number which is returned. Simples. And that's it for another video. Thank you ever so much for watching. I really hope this video has been of some use to you. I know these AMOS tutorials that I'm doing are getting a lot of love out there, so thank you everyone for your kind comments and your support. It really means a lot to me. So you can find me on the web. I've got my website, I'm on Twitter, I'm on Mastodon, I have a KoFi account as well. All those details probably scrolling up the screen now, or they're in the video description down below. So thank you once again. If you like this video, give it a thumbs up. If you want to subscribe to my channel and catch more of these videos as I produce them, and believe me, there are more AMOS tutorial videos coming. I'm working on the next one already. Please like and subscribe and all that good stuff. Take care of yourself, and whatever you do, keep it retro.